Hello and welcome back to Higher Maths Functions and Graphs Sketching Parabolas. So we're going to look at questions 4, 5 and 6, which are slightly different. So question 4, we're given a sketch of a parabola and we need to find the equation of that parabola. So how do we go about doing that? Well, we know that the roots here, because the parabola is just touching the x-axis from National 5, we know there will be a repeated root. So repeated root at x equals -5, x equals -5. So the same root, the same answer twice. So if we know the root, then the factor, what we've got in the bracket, will be x plus 5 both times. So we would have y equals x plus 5 all squared. But of course, we know that that graph may have been stretched or squashed vertically. Okay, so we can't just say y equals x plus 5 all squared. We need y equals k bracket x plus 5 all squared, because it may be 2 bracket x plus 5 all squared, or 7 bracket x plus 5 all squared, or 0.1 bracket x plus 5 all squared. Okay, so we know that x and y coordinates are related together by this rule. Do we know another point on the curve? Yes, we do. We know that when x equals 1, y equals 6, because we're given that point. So when x is 1, y is 6, we're just going to substitute in. So 6 equals k bracket 1 plus 5 all squared. So 1 at 5, 6 squared is 36. So 36k equals 6. Divide both sides by 36 and simplify. And k equals 1/6. So the equation of this curve would be y equals 1/6 bracket x plus 5 all squared. Okay, so we've got a second example like that. Question number 5, find the equation of the parabola shown below. So we know there is a maximum turning point at 4, -2. So if we think about y equals x squared, which is a positive parabola going through 0, 0, then how would we transform that graph to make it look like the one that we're given here? We would have to move it along 4, down 2. So how do we do that? Well, we do x minus 4 bracket all squared minus 2. It also needs to be flipped upside down, so we'll need to multiply by the whole bracket squared by a number. That number will be negative, but we don't know if it'll be -1 or -4 or -5 or -0.2. Okay, so we'll just call it a just now. We could use k. So y equals a bracket x minus 4 all squared minus 2. Again, the a is going to stretch it and also flip it upside down. The x minus 4 would move it from 0, 0 along to 4, 0. The minus 2 would move it from 4, 0 down to 4, -2. Now again, just as in question 4 there, we're given another point on the curve here. When x is 0, y is -7 at this point. So we're just going to substitute in. So we end up with -7 equals 16a minus 2. Add 2 to both sides, and then divide through by -5. So a equals -5/16. So we know it's of this form. We've just worked out that a is -5/16. So we just need to rewrite the equation there. So y equals -5/16 x minus 4 all squared minus 2. And question number 6, which we can do by sketching the parabola, although we just need to understand that we can answer the question that way. Show that this is positive for all values of x. So what we can do, we can consider this equation and this curve. We can complete the square on it like we have been doing. So we've had a lot of practice at that, so that should be fine now. So multiply through by 2, do 33 minus 9 halves, which would be 28.5 or 57 halves. So comparing this to just y equals x squared, it'll be stretched by a factor of 2, move 3 over 2 to the right, and moved up by 28.5. So if we make a little sketch of that graph, the question is saying show that 2x squared is positive, or 2x squared minus 6x plus 33, is positive for all values of x. Well, it is always going to give a positive answer. The minimum value would be 28.5, which happens when x is 3 over 2. For any other value of x, you're going to get a higher value than that. So therefore, it's positive for all values of x. We could have used that using b squared minus 4ac, but I'm just showing you how to do it by sketching a parabola.